Good evening, good evening, good evening, and welcome to day 4 of the Advent of Code. My name is Max. I am still a software engineer, professional software engineer, and we're going to be solving today in Rust again. I have not even looked at today's. I've skimmed today's puzzle in that I have scrolled to the end of it, downloaded the input, and now it's time to actually work out what's going on. So, space needs to be cleared before the last supplies can be unloaded from ships, and so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try and quickly find overlaps and reduce duplicated efforts, the elves pair up and make a big list of section assignments for each pair, which is our puzzle input. So, for example, consider the following list of section assignment pairs: 2468, 2345, 5779, 2837, 6646. Intriguing. That elf doesn't seem to be doing much work at all. 66. Maybe 6 is huge. Who knows? 26 and 48. So for the first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2 to 4, 2, 3, 4, and the second elf was assigned sections 6 to 8, 6, 7, and 8. The elves in the second pair were each assigned 2 sections. The elves in the third pair were each assigned 3 sections. One got 5, 6, 7. The other one got 7, 8, 9. This example list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pairs of section assignments might look like this. Very exciting. Yes. Interesting. I'm saying interesting. Hey, Copperfield, how's it going? I'm this kind of layout is very suspicious to me. I have a feeling I might know a good way of solving this. Some of the pairs have noticed that one of their assignments fully contained. Oh, fully contained, but okay, maybe it's not what I was looking for. Exciting. For example, 2 to 8 fully contains 3 to 7, and 6 to 6 is fully contained by 4 to 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning, so these seem like the most in need of reconsideration. In this example, there are 2 such pairs. In how many assignment pairs does one range fully contain the other? Okay, cool. I was wondering if it was going to be a it might actually still be an XOR puzzle or a bitwise puzzle. So what I'm getting by that is that if we think about Copperfield says, I'm also participating in the Advent of Code. Excellent. Are you on day 4? That's the real question. If we look at assignment of bits, so in a byte we have 8 bits, and in a number of different bytes we can have even more bits. If we set the bit at each position, so let's say 2 to 4, so we set bit 2, bit 3, and bit 4. This is one way of doing it. I'm not saying this is the right way of doing it. Set bit 2, bit 3, bit 4, and then we have bit 6, bit 7, bit 8, and then we do a bitwise and between the two. Then if that is equal to one of the two, oh no, does that work? That gives us a number. That gives us that gives us an assignment of bits, which maps to a number. So 2 to 4 would be bit position, because it's good that we're going to be 0 indexed. So there could be some interest there. I mean, we can just write shift by the numbers. So a bitwise 2 would be a 4. A bitwise 3 would be an 8. So that's 12. A bitwise 4 is a 16, so that would be 28. That number would come out as. So then we bitwise and them together, and if the outcome of that is equal to one of the input numbers, then I think that is included within the same one. I'm not saying that's the right way to do it. I'm just this is really pushing me in my brain towards bitwising. Like, I'm sure there's an easier way. I'm sure there's other ways of doing this, but it feels like I want to do bitwise stuff. So let's do bitwise stuff. So let's take our puzzle input and let's go to our tests for day 4. We are doing this in Rust as per usual. I've don't know what I've managed to do there. That's extremely kind of helpful by that's kind of helpful by Visual Studio there. It created me a new folder, but sure. Okay, so our input is this. So we need a way of turning these into ranges, which should be relatively straightforward. Because they look like it's relatively easy to parse this pattern. Now the question is how we're going to parse that pattern. Where we could use regexes. Regexes will be fun. Now we have 2 problems. But we'll see. So let us. How are we going to start? We're going to start the same way we usually start. There we go. We'll have a test. An example, step 1. Okay, so our input is this. So we want to split it first at the comma. If we split it at the comma, that gives us the 2 elves. So elf1, elf2 equals, and we're just going to start the first line 2 to 4, 6 to 8. I'm just going to type that in manually. Dot split at. Not split at. Can I just do split? Pattern can be a character, so we'll do that. Actually, I mean, we could just split on hyphens as well. That would also do a good job. Split gives us, what's that going to be? Split gives us a split pattern. Dot collect. How do I? There must be a split 2 then. Split once. There we go. There, that's what I wanted. I'm just going to unwrap that for now because laziness again. So that is going to end up with an elf1 and an elf2. So obviously, if we stick in some good old debugging here, elf1, elf2. There we go, and printer out. It's going to just simply print out 2 and 4 and 6 and 8. Good, as we expected. So split split assignments into elves. Split elves into ranges. So I'm just trying to think the best way at the moment of doing this. I'm trying to think if I can get ranges out. What I would like to, what would actually be really cool is converting a string like this into an iterator, a boxed iterator. I want to see if that works. So I'm going to try and write something for that. Range to iterator. It's a bit of a misnomer here. I'm going to actually throw some range str in just because we know it's a string slice. And for the moment, I'm not going to have a return type. Again, so we want to start with the start. So start end. It's going to be an inclusive end as well. So I'm just going to put that in. Inclusive end equals input dot split once, and the splitting here is done on hyphens. I'm just going to unwrap that as well, just for now. We can add some error handling later if we absolutely need to. I kind of want to get tonight done as soon as possible because the office is a little bit cold, so I'm happy to be a little bit lazy. Let's start equals u32. No, I want to do start dot parse, and I'm going to parse it as an unsigned 32. To be honest, then we should probably be throwing back a result. Now, what is our result type going to be? I would like it to be a din iterator, actually. A boxed din iterator. Let's see if that works. And then an AOC error. So that's our error type that we have. We made it. It's very, very straightforward. It's just a string. Or it's an enum over string, so that's fine. Close that up. Why are you complaining? Because you haven't defined what an iterator is. No, I haven't defined what the iterator type is. That is true. Item equals unsigned 32. Now you're complaining because I haven't returned the right type. That's fine. I will do that in a second. Give me a chance. So start is a u32. Inclusive end is inclusive end dot parse unsigned 32. Why are you complaining? Oh, because yeah. So what's actually happened there is that because the error type is not the right type, what I could actually do here is just do an anyhow error instead. Given that I don't care what the error type is, I'm just going to throw it away. At least I'm going to hope I can throw it away. And I'm just going to finish this off with an OK and close, and hopefully, yeah, it's only erroring on this because it's like, oh, I expected you to give me a thing, and I haven't given it the thing yet. So what I actually want to do now, I'm trying to think if there's just a straightforward way of generate range Rust stud ops range. Okay, so a stud ops range. Can I just construct a stud ops range? That is the question. I may just be able to construct one of these. The alternative is to do let x equals box new and then start dot dot inclusive end plus 1. And I think that might actually work. If I do OKX here, yeah, the compiler is pretty happy with that. So what I've essentially done here is create is have a range, and then I've boxed that. So that's allocated a wrapper around it, which means it can be allocated again. There's I'm trying to think exactly why this works. Basically, if you don't do it, the compiler is going to shout at you. Is generally the right thing. So yes, I have allocated some memory here, and the what we've said is that inside this box is something that will iterate over unsigned 32-bit numbers, which is exactly what we want. I mean, possibly we don't even need this. Possibly we just need to change the range string to a byte. Maybe I'll just do that instead. Maybe that'll be easier because I'm just going to have an actual number. Yeah, maybe I'll just return a number. That would be useful. So range str to byte num. There we go. And so because it's an inclusive end, I'm going to say let out mute output equals 0, and then I'm going to for idx in, I'm going to do start to inclusive end. Output, and then we're going to bitwise shift, or we're going to set the bit at the right value. So I'm trying to think exactly how we do that. Is it going to be one left shift or two left shift? I think it's going to be one left shift. It doesn't really matter in the end. I'm going to see if this works. Output and equals 1 left shifted by index is what I want to actually end up with. Stick some brackets around it. The compiler might say these brackets are unnecessary. These brackets are unnecessary. Thanks. Good. Okay, so what that's doing is it's setting the bits that we need. So if I now say let x equals range to byte num of elf1, that is going to give me out an error, and I'm just going to query mark that, and then I want it to just print me out the value here. So I'm hoping that if we just run this, it will. Oh, okay. It's coming out as 0. Oh, am I left shifting rather than right shift? This is where no, I want to be left shifting, don't I? Pretty sure I want to be left shifting. Maybe it is 2. I want to be left shifting a 2. Let's see. Let's try that. Okay, that's exciting. Debugging, the best thing you can do in programming. Trying to work out what your program is doing at each step of the way. Making range was always the first thing I thought of. Excellent. Okay, so this is saying to me, for some reason, we don't have a start and an end, and it's not printing anything out for those. That seems suspicious. So I may or may not have done a dumb thing. Happy to have done a dumb thing if we work it out. Okay, scrolling up. Okay, so it is printing out those the indices correctly. Oh. Sorry about that. That is I've switched something over in the infrastructure of the house, and it's causing some issues, but I will sort it out. How am I going to sort that out while streaming? That is a good question. Never mind. Yeah, so I think this should be working. I think it should be bit shifting. If it isn't, that is exciting. Give me 1 sec, and let me just sort this problem out, and I'll be back in 1 second. Live signing into Spotify. There we go. Okay. I think I want to print out now what this value is as well. There we do. Let's do that. Maybe this is what's causing the issue. Oh, yeah. It's because I'm being dumb. Always being dumb. There we go. Right, let's try that. Not and equals, or equals. 28, good. That's the number I wanted to see. Fantastic. Right, give me 1 sec. I'm going to try and log out of this account on my phone. Good. So now we have the ability we have the right number coming out of this. Excellent. So now let's elf1 val equals this, and let elf2 val equals this. So we should be able to print those out as well. And those should give us some interesting things. Yeah, 2 and 448. And now I'm going to just say overlap is this elf1 val or elf2 val, and that should be 0. Log in. Why are you complaining? Help. Oh yeah, I need to add a semicolon. That would help. All right. Log in. Overlap is okay. So yes, there is some overlap. Why is there some overlap? No. Again, wrong thing. And. Not or, and. Yay, bitwise logic. Overlap is 0. Fantastic. Good. That's what I wanted it to be. So if we change this to a 6, for example, I'd expect there to be 1 bit of overlap, which is the 6th bit. And again, that is, 64. So I think if it's entirely encompassed, so the ones that are entirely encompassed was 2 to 8 and 3 to 7. 2 to 8 and 3 to 7. My hypothesis is when we run this, 248 equals one of the numbers. So if one of these numbers is equal to the overlap, therefore one of them is entirely inside the other. That is logic. So, all right, there we go. Can we play on there? We press play. Wonderful. The benefits of technology. Excellent. Good. So we have a function. We have a way of doing this. So in fact, we probably just want to be just writing a new function, which is encompass check. Sure, why not? And we'll go elf1, which is going to be a string slice, and elf2, which is also going to be a string slice, and this is going to just be a bool. All we're going to get out of this, and then we do pretty much exactly the same thing as here. We get the elf1 value, the elf2 value. Probably do want this to be a result bool actually. So we'll just do anyhow error because we don't actually care about the error. If there is an error, it will just bubble up to the top. That's fine. So now we're going to return. So yeah, let and elf1 and elf2 equals elf1. It's not a great name. It's probably a better semantic name for this, but so we're going to return the result of elf1 and elf2 is equal to elf1 val, or elf1 and elf2 value equals elf2 val. That's right, isn't it? Oh yeah, and we want to wrap that in an OK because this is a result, obviously. And then we have an encompass check. So, yeah. Let res equal encompass check elf1, elf2, question mark. Encompassed is res. That's all we care about. We don't care which elf is, we just care that an elf is. Encompassed, true. So if I now change this to 6, for example, we should get encompassed false. And we do. Excellent. So that's example 1 sorted. So we don't even need, we're just throwing away our custom error type. That's fine. So we're going to go back to our day 3. We're going to take our step. And we're going to read in the input from today. Wonderful. And we're going to return no errors. And so what do we want to do? So we want to iterate over the lines, obviously. We want to filter. Yes, filter would be a decent option, wouldn't it? So filtering is our line. I think I do that. That gets rid of the double string. Yeah. Okay, so we have a line. Our line looks like this. So we say let elf1 elf2 equals line.split once. Delimiter is a comma. We're just going to unwrap it again. Could add some error handling, but for the moment probably fine. And then we're going to the output of this is literally just going to be oh, this is annoying. Okay, what I'm actually going to do, I'm going to map this. So pretty much the same concept. We're going to have lines. I'm just going to iterate over these, not so I do want that that reference, and we're going to use pretty much exactly the same functionality here, but that's going to be an option. I am going to add error handling. Are you aware of assert? I am aware of assert. That is true. I have got assert. If I want to assert on stuff, I can assert on stuff. That's true. Let's do some pattern matching. So this should end up with a sum if I do sensible stuff like this. Right? You are very complaining at me about something and I don't know what it is, compiler. Give me a second. Consider using a semicolon here. Okay, yeah, I will do. Give me a second. Give me a chance. And then we got none is going to be what I'm going to actually spit out here is an AOC error. There we go. Finally get around to using one. Line couldn't be split. A very different pace than my own solutions. I'm pretty well. Yeah. Hopefully, I'm trying to explain it at the same time. I'm not aiming for speed here. I'm sure if I was doing it without trying to chat at the same time, it would also be a little bit faster, but wouldn't be as much fun. So you know, I'm happy. As long as you're happy, I'm happy too. So I'm just going to say let x equals this for now. I'm going to throw away all this code at the bottom. I don't care. AOC error. Why are you complaining? Oh yeah, because I actually want to be. Yeah, I want to be calling a thing. Are you aware of unimplemented? You can use it to make sure the types work out. Yes, I do. I tend to just assign it to a variable. Generally at the moment, I when I'm trying to work out what types actually are, I just assign things to variables and it tends to be fine. This is actually an error type is what I want to get out of this. And what I want to get out of this is I want an encompass check on elf1 and elf2. So this, I'm hoping, is mapping to a result. Why are you complaining? This is found to be a type anyhow. Oh yeah, okay. Oh, it's because anyhow, I've got one type is an anyhow error. I should be able to just do this and there we go. All the problems go away. Type.into. What this is doing is converting our AOC generic error into an anyhow error, and therefore it makes the two branches match up, which is lovely. Okay, so now we have an iterator of results going to bools, and I'm just going to collect that as a result of vectors of bools, and then I'm going to question mark it. So now we end up with a vector of bools. And then I'm going to iterate over my vector of booleans. and I'm going to filter on my vector of booleans b, and I'm just going to return b as the boolean. That's the boolean value I want. I need 3 question marks there, and then I should be able to do .len on the final thing. I'm hoping. I'm sure there's going to be at least one complaint here. Oh yeah. Let's do... That should work, right? Result. Yeah, okay. Yeah, anyhow. Error. There we go. Now what are you complaining at? I've got that in the wrong place, probably. Result. No, that should be fine. Maybe I've got that in the wrong place. Oh yes, I have. Yes. Is it there? Perfect. Excellent. Good. And you're complaining because you expected a bool and you found a start bool. That's fine. We're going to just dereference you, and no len found for stud iter. That's interesting. Instead of writing the whole anyhow thing, you can just write an underscore. Ooh. Awesome. I am a professional Rust developer. But I do tend to be a little bit overwinded sometimes, shall we say. I do like stuff like this. I do like being more explicit over implicit, where I can be. Sometimes it's nice to be. I mean, in theory, actually, I could probably throw most of this away. Well, I suppose the vec bool I can't, because that's the type I actually want. But yeah, the underscore there is just saying, oh, we don't care, just work it out. .count, good, that's what I want. .len, yeah, there's no len in a thing. Good. All right. So that should be our. I'm going to call this encompassed. There we go. What a good name. And all we have to do is to work out our solution is print out our count of encompassed elves, and hopefully. How are you enjoying this year's AOC so far? I'm one of the maniacs trying to race for global leaderboard points. Wow. I'm certainly not aiming for any sort of leaderboard. I'm not even trying these at the start of the day. I'm just trying to. Wow, that was a lot of failure. Tempted to shift left with overflow. Ooh, are we too big? Am I too big? I may be too big. Maybe I need to be at unsigned 64s. Ooh, exciting. Maybe my solution is not ideal. I may have bossed too close to the sun. You know what? Screw it. Let's go for 128 bits. That gives us 128 ranged sizes to deal with, right? I'm sure that will be enough. I'm sure it'll be enough. Right, let's retry that. But yeah, as you can see, sometimes we fail. How am I enjoying it? I'm actually enjoying it a lot. So that was good. Have you seen that ChatGPT was able to solve Advent of Code? I've seen very weird stuff with ChatGPT today. I do not know exactly how it's doing it. I saw that I don't know how much of it is real and how much of it is fake, to put it that way. Like I've seen somebody who started doing like Python programming inside ChatGPT to then connect back to ChatGPT to then start a session with ChatGPT inside the emulated ChatGPT, which is insane. Just what? I have no idea. Excellent. So we got the right answer. 32 bits was not enough, which is mildly worrying. I don't know how big the inputs are, but 128 bits was fine. So that's good. If it gets any worse than that, we might have to implement a different solution, and that's also fine. But that was so much faster than yesterday. Like yesterday, by this point, oh god, it's 35 minutes in. I thought by at this point yesterday, it was like, oh, we're still most of the way through. So There's definitely a bit of discourse with people solving these years with AI. There was a leaderboard result in 10 seconds for part 1 on one of the days from an AI. Wow. That is wow. I don't know how to respond about that. That's nuts. Oh, here we go. In the first example, the first 2 pairs don't overlap, while the remaining 4 pairs do overlap. 5 to 7 overlaps in a single section. 2 to 8 overlaps in all the sections 3 through 7. 6 to 6, 4 to 6 overlaps in a single section 6. 2 to 6, 4 to 8 overlaps in sections 4, 5, and 6. So in this example, the number of overlapping assignment pairs is 4. In how many assignment pairs do the ranges overlap? Well, thankfully, my solution means that we're actually going to solve this in a very, very fast time today. Thank goodness for that. So, yeah, I'm going to just switch this up very slightly. So we're going to go, I'm going to call this L4. There we go. That's a good name for a function. And it's going to return an unsigned 128 number, and all it's going to do is return this value. That's annoying. No, it's not going to do that because I have to return. I'm actually going to return 3 unsigned 128 numbers. I might just return 2 unsigned 128 numbers. That would be fine too, because obviously we can just. It feels like returning 3 makes more sense, but returning 2 is also fine. Yeah, I don't want to think too hard about this at all. So let's go elf1 val and elf2 val and wrap this again in some brackets. There we go. And we're going to say let's elf1 val, elf2 val equals L4 of elf1, elf2 question mark. That should give us, this should basically give us the right thing, and then this is calculating the and or. Yeah, that's fine. So this is the encompass check, and then we want to do an overlap check rather than an encompass check. So overlap check is just going to be similar, and we want to say if elf1 and elf2 is not equal to 0 or greater than 0 or any of the other things. If I was doing this, I'd just panic on everything instead of proper error handling. I was trying to be professional about this. I was trying to show people how to do this slightly more properly. But yeah, you certainly don't have to do this in this kind of code. By the fact that I'm copying and pasting a lot of things. But yes, ideally there are different ways. So overlaps, and instead of our encompass check, we're going to say an overlap check, and we're going to change encompassed to overlaps, and overlaps, and hopefully we say there are 905 overlaps, and that's the correct answer. So it's nice when your assumptions, professional software devs copy a lot too. Shh, that's our secret. That's our secrets. You're giving away our secrets here. No. Let's be fair. Sometimes it's correct to be copying. Sometimes it is correct to be copying. Sometimes it's not correct to be copying. And sometimes it's right to be refactoring out of things, but there has to be one of the things you actually learn. We finished the day, so feel free to leave if you want. But yeah, one of the things from software development that I find is interesting is that as you start out, very quickly you'll realize that there are other business cases than doing the 100% objectively correct thing. So if there is code that is bad, there is always code that is bad. That is always the case. There will always be legacy code of some description, unless you are writing something completely from scratch. If you're writing something completely from scratch, you're probably doing it wrong. You're probably not leveraging other people's code. You're probably not leveraging open source effectively. You're probably not doing the right thing there. But if you are writing things 100% from scratch, obviously that's fine. But again, then you have differing pressures on you. So some of the code you write at the start of a project, as time goes on, is going to look a lot different from the end of a project as well. And so yeah, there are options at each point for saying, should we be copying and pasting this code? Like, the answer is usually no. I mean, if copying and pasting is one of those code smells, which is like, yeah, we should probably not do that. On the other hand, if you've got somebody breathing down your neck at 5 o'clock on a Friday, yeah, what's you need it delivered now. You need a solution now. It is absolutely fine in that case to be copying and pasting. You getting the right thing, obviously going through testing and stuff like that. Copying and pasting tests, probably a good plan. It is a code smell. It's not the end of the world. It is technical debt, basically, and it is a debt that you get on software, and you have to pay that debt down at some point and make sure people who are paying you to write your software understand that that is a thing that exists. But one of the things I had to learn in my career, not very early on, but sort of as you grow out through your career, it does make you a little bit jaded. It makes you feel like you're jaded, but no, there are other business concerns. Like you might be seeing the wood for the trees. You can see that this code obviously needs fixing. That's fine. Your managers are saying that actually 6 months down the line, this whole thing's being scrapped anyway, and there's no point in investing a week's worth of somebody's time when actually it's going to be thrown away in the end. So yeah, there's a time and a place to do that, and as you get older in your as you go through your software development career, you will learn the time and the place to be pushing. And there are some times where you actually you say, no, actually this is the right place, this is the right time and the right place to be making these changes. So you need to be doing, we need to be investing here, and that's when you start becoming senior level. And if you can sway people to your side, even better. Anyway, that was day 4 of the Advent of Code. We solved that with bitwise comparisons. Bitwise comparisons are very, very useful. So that's always good. That's the end of the stream. I will be back tomorrow. I would like to see, actually, just briefly, how chat did their solutions. Happy to spend a couple of minutes just hearing about how chat did their solutions. This bit manipulation was interesting. At first I thought it was just making a range, putting it into a set and solving with a set operation. Okay, so a very similar thing. Very similar thing there with the sort of sets going on. That's quite cool. So it is exactly the same thing, actually. Like, if instead of instead of what I had here, where I've made a range, I could gather those numbers into a hash set of integers, and then it's exactly the same thing. And in fact, like, we've got a couple of minutes. Let's show you how fat. Let's see what. Let's see if we can turn this into a result without using bitwise manipulation. And I'll show you how quickly I'll hopefully show you how useful it will be to do in Rust. So let's see. So I want to return a hash set of unsigned 32 numbers. Okay, that is what I want to do. It's going to complain because I haven't defined hash set, so I'm going to import hash set. So this is a range struct to byte num, so we're going to end up with, so we want to have a hash set of U32. So we do this, and then we do dot collect, and we do OK. Oh, I thought that, I was hoping that was going to work. Oh, it's because it's not 128-bit numbers. These actually, I can drop these down to U32s now, because I do not think we're going to need 128-bit numbers. So, good. So this magic line basically takes our range and collects it, and automatically turns it into the type up here. So hash set U32. Good. So now we have a hash set of U32 values. We are just going to be returning hash set of U32, hash set of U32. Sound good? Yep, good. And then an encompass check. Okay, so now we want to see, now this is going to be the interesting one. So the encompass check is kind of interesting. So we have, So what do we want when it comes to this? It's going to be the intersection, right? Yeah. Int equals, oh, that's a really bad name. Let intersection equals elf. Let's call it an elf intersection. Elf1 val dot intersection of elf2 val, and then we're gonna we have to, because it's an iterator, we have to collect it again as a hash set of unsigned 32-bit numbers, hopefully, and this is actually a reference. And then you're complaining because for some reason you're complaining. I don't know why you're complaining there. Why are you complaining? This is an intersection. It should have an iter method on it. Okay, I will. The IDE is not giving me what I want here, so I'm just going to cargo test this. Value hash set U32 cannot be. Oh, right. Yes, this is the problem I had yesterday. Yes, I know. Copied. Good. Okay, so copied turns our iterator of U32 references into an iterator of U32 hashes. Like, possibly we could. We don't necessarily need to do this, but it's fine. So we have the elf intersection. So now I think I can do that and do that value. So this is going to compare the two sets. So I feel like if we do this again, oh, why you can? Oh, yeah, okay. It's complaining because I haven't made this work yet. So I think I will just fix this up first. So let's, again, it's going to be let elf intersection equals this, but this time we just care about if there actually is an intersection. Should be like, I'm just trying to think if there's an is empty count. I'll do a count. There you go. There we go. Close. Oh no, I actually do need to. No, that's fine. Actually, I was gonna say that's fine. Good. Okay, so example step 1 again. I'll just run it again. So yeah, encompassed is false, and then we switch. Which way round did we have to switch this? This was 2 to 8, wasn't it? And this should come back to encompassed true. It does. And then we run this value 576, and then we run this value, and it gives us 905. Good. So again, we could do it by sets, and I think sets is probably the more maintainable solution going forwards, because obviously there is a limit to the length of the numbers you can use if you're using bitwise comparators. So yeah, we hit the, well, we actually hit the error up front saying why can we not do it this way, because we were using unsigned 32-bit numbers. So we moved to 128-bit numbers, but that is not a good long-term solution. So obviously sets is the right way of doing it, and that's the way that we will commit. So that is day 2. I hope you enjoyed that. I will be back again about 8 o'clock ish British time tomorrow for day 5, and hopefully something that doesn't involve sets would be nice, given that we've had sets 2 days in a row. But that's it. I hope you had a good time. Yeah,